Level 3 students. My name is Fiziwe. You will remember me from the last lesson. Our subject today is still mathematics, and we are going to be dealing with the same topic that we discussed in our first lesson, which is space, shape, and measurement. Our subject outcome is still 3.3, which is the use of the Cartesian coordinate system to derive and apply equations. You will remember that in our first lesson, we derived and applied the equation of a line through two given points. In this lesson, we are going to determine the equation of a line parallel to another line. And then we'll also determine the equation of a line perpendicular to another line. And then in our third lesson, as I said earlier on, we will derive and use the angle of inclination of a line and look at typical examination questions. Our pre-knowledge, which is what we bring from level 2, is very much similar to what we discussed in our lesson number 1. We are still going to deal with the Cartesian coordinate system, the x and y axis. We are going to be dealing with the plotting of ordered number pairs or the plotting of points, so the xy coordinate system. And then we are going to deal with parallel lines. And by way of definition, lines that are parallel, they are equidistant from each other. And the word equidistant means they've got the same distance apart from where they start to where they end. We are still also going to look at the equation y is equal to mx plus c, which is the general form of the straight line equation or the linear equation. And m still remains our gradient, and c is a constant, which is also the y-intercept. Now let us look at today's work, where we are going to determine the equation of a line parallel to another line. Now, a point that needs to be noted here is that if lines are parallel, then their gradients are equal. We can say it in the reverse way, that if the gradients of given lines are equal, then we can conclude that those lines are parallel. So we need to use that in our next example, which is example 1. We are going to determine the equation of the line that cuts the x-axis at 4 and is parallel to the function or to the equation y is equal to 2x plus 6. On this slide, I'm going to show you the steps that we are going to use. First, as we discussed in lesson number 1, we can do a sketch, which is again, like I said, an optional step, but I encourage you to do that. Then from that, we're going to determine the gradient from the given equation, which is the given equation y is equal to 2x plus 6. And once we determine the gradient from there, we then use the general equation and the gradient to determine the equation of the line number 2. Now let us go to the board and show this. We are given the equation y is equal to 2x plus 6. This is quite straightforward because the equation is written in the form y is equal to mx plus c. So straight on from this equation, we can see that 2 is the gradient. So already without any calculation, m is equal to 2. So we now already have the gradient. We are also told that this line or this graph, it cuts the x-axis at point 4. It is cutting the x-axis at point 4. Therefore, the coordinate where it cuts the x-axis, it will be 4, 0, because it cuts the x-axis at 4, and therefore the coordinate will be 4, 0. Now we have got the information that we need to determine the equation of that line, which is parallel to this line. Okay, so now we can then substitute these coordinates and the gradient that we have just determined into our general equation, which is y minus y1 is equal to m in brackets x minus x1. Substituting then becomes y minus y1 is our 0 is equal to m, which is 2 in brackets x minus x1, which is 4. And then we simplify that. Y is equal to 2x minus 4. This becomes the new equation, or the equation of the new line, which is parallel to that line. You can see that also the gradient, which is the coefficient of x, is 2, just like that gradient there. So because they've got the same gradients, they will be parallel. The only difference is that the first line will cut the y-axis at 0.6, and this will cut the y-axis at minus 4. Just to refresh our minds about the sketches, it would look like this. Then this will be our 6, and this will be our minus 4. So this one, which cuts the y-axis at 6, would generally look like that. And the next one, which cuts at minus 4, will be like that. And they would be parallel lines. Let's move on to example number 2. In example number 2, we are going to determine the equation of the line which is parallel to the line 4x plus 2y minus 12 is equal to 0. And that line will be passing through the point 3 minus 5. In form of the solution, we first have to rewrite the given equation. 4x plus 2y minus 12 is equal to 0. We have to rewrite this equation in the form y is equal to mx plus c. We need to do this because from this general form of the linear equation, we can then conclude that the coefficient of x would be the gradient of that line. In this case, we cannot take 4 and assume that it is the gradient of that line. We have to rewrite this equation in this new form. And then after that, we will then be able to determine the gradient of that equation, which will be the same gradient for the new line. And then, like we did earlier on, we will substitute the gradient and the coordinate into the general equation and then simplify everything. Now let's go to the board and demonstrate that. Our equation is 4x plus 2y minus 12 is equal to 0. We need to rearrange this equation in the form y is equal to mx plus 2. And if you do all that, you will find that y is equal to minus 2x plus 6. So if we rearrange this equation and write it in the form of y is equal to mx plus c, it will end up like that. And therefore, we are now clear because we have written it in the form y is equal to mx plus c. So already our gradient is minus 2. I can safely say, therefore, m is equal to minus 2. Then we are told that this line will also cut through the point 3 minus 5. So we also have the coordinate 3 minus 5. So what we have only done here, which is different from the first example, was to rearrange this equation in the form y is equal to mx plus c, so that we could determine the gradient. Now we've got the gradient and the coordinate. We go back to the general formula and substitute into this information into that equation and determine the new equation of the new line. It will be y minus y1 is equal to m in brackets x minus x1. This will be y minus y1 will be minus 5. Don't forget again, this negative sign belongs to the formula. This negative sign comes with the y coordinate. And then m is minus 2 in brackets x minus x1, which is 3. This gives us y plus 5 is equal to minus 2x plus 6. Again, two negatives give us a positive. Therefore, y becomes minus 2x and then plus 1. So that becomes the new equation of the new line. You can see again that when we wrote this one in the form y is equal to mx plus c, our gradient was minus 2. It agrees with the new gradient. Because these two lines are parallel, their gradients would be equal. The only difference, once again, is that this line cuts the y-axis at 6, while this one will cut the y-axis at 1. Now we'll need to move on to look at the second part of our lesson, where we are going to look at determining the equation of a line which is perpendicular to another line. All right, in the second part of this lesson, like I said, we are going to determine the equation of a line which is perpendicular or orthogonal to another line. I just gave these two words so that you become aware of them. Sometimes examiners want to use the word perpendicular, and sometimes they use the word orthogonal. You should remember that they mean the same. Now, what are perpendicular lines? Or what does perpendicular mean? Perpendicular means that the lines are at 90 degrees, or they are at a right angle to each other. That's what perpendicular means. Now, the gradient of a perpendicular line is equal to the negative reciprocal of the original gradient. I think it would be important here just to explain a little bit what the word reciprocal translates to be mathematically. So let's look at the board. Now, if I have a number 4, the reciprocal of 4 the number 4 can be found by dividing 1 by 4. Therefore, the reciprocal of 4 is 1 over 4. So the reciprocal of a number is found by dividing 1 by that number. So the reciprocal of m becomes 1 over m. The reciprocal, therefore, of 1 over m, it is m. So this is the reciprocal of that, and this is the reciprocal of that. So to determine the reciprocal of a number, if it is usually a whole number, then we divide 1 by that number, we get the reciprocal. Now, when we are talking about perpendicular lines, we are saying, if I've got a line like that, and the gradient of this line is m, then I have another line which is perpendicular. And this is how we show that they are at 90 degrees. So if the gradient of this line is m, the gradient of the perpendicular line to the first line will be the negative reciprocal of the original gradient. That's how the relationship of the gradients apply on the perpendicular lines. So if two lines are perpendicular, now the product of their gradients is always equal to minus 1. And we normally show this by a small equation which says the gradient of the first line times the gradient of the second line is always equal to minus 1. This is a very important relationship when we are dealing with the gradients of perpendicular lines, because we can then, if we know the gradient of one line, we can then use it to find the gradient of the other by using this relationship. We know that the product, in other words, if we multiply the two gradients, the product of those two gradients is always equal to minus 1. And this is a relationship that we are going to use in this part of this lesson. So in our first example, we are going to determine the equation of the line passing through the y-axis at 3, and that line will be perpendicular to the line y is equal to minus half x minus 2. And so In terms of the solution, we have to determine the gradient of the given equation. We already have an equation given to us. So from this equation, we should be able to find the gradient, or to determine the gradient of this equation. The next thing we need to do then is to then calculate or determine the gradient of the second line now, which is perpendicular to the given line, using the relationship that I've just demonstrated on the board. And then we then substitute the gradient and the coordinates into the general equation and then simplify. Now let's see how that pans out on the board. Our equation we are given is y is equal to minus half x minus 2. So that is the equation that we are given. So from this equation, if we call this line 1, therefore m1, which will be the gradient of this line, it is minus 1 over 2, because that's what we have in the equation. Therefore, the next thing now would be then to find m2, which will be the gradient of the line that is perpendicular to that line. So how do we get that? We then say m2 times m1 is equal to minus 1. We don't know m2, so m2 times minus 1 over 2 is equal to minus 1. If we take the 2 to that side, it becomes m2 times minus 1 is equal to minus 1 times 2, which is minus 2. And then m2 becomes your minus 2 divided by minus 1. And therefore, m2, the gradient will be 2. So if the gradient of the first line is minus half, the reciprocal, the negative reciprocal of this gradient is going to be 2. You should be able to remember this from what I said earlier on. So now we have got the gradient of the line that we are worried about. Then we also know that this line, it is cutting the y-axis at 3. Therefore, the coordinate will be 0, 3, because it is cutting the y-axis at 3. So the x component will be 0, and the y component is going to be 3. Now we are equipped with what we need to determine the equation of the new line, or of line number 2, because now we have got its gradient, and we know somewhere where it cuts an axis, or where it cuts the y-axis. Then we go back to our original equation. Y minus y1 is equal to m in brackets x minus x1. This becomes y minus our y1, it is 3, is equal to m, which is 2 in brackets x minus x1, which is 0. And therefore, that becomes y minus 3 is equal to 2x, and then minus 2 times 0, it becomes 0. So we don't necessarily need to write it, but we can write it, it doesn't matter. So it becomes minus or plus 0. Then that becomes y is equal to 2x. 0 minus, minus becomes that one, so it becomes plus 3. So that becomes the new equation. Y is equal to 2x plus 3. The new gradient is 2, the one that we calculated here, and we can see again that this graph will cut the y-axis at point number 3, as we have been told there that it will cut the y-axis at point 3. And this is our constant, or the y-intercept. It will agree with our coordinate and what the question tells us to do. Quite simple. Right, in our second example, which won't be very different from what we have just been doing, slightly longer, but still the same concepts that we are going to apply. You will also see that we are going to look back at some of the content that we covered in level 2. In this question, we are determining the equation of the line orthogonal or perpendicular to the line y is equal to minus 2x, y minus 2x is equal to 4, and passing through the midpoint of 5, 3, and 1, 7. So there are two things that we need to do here, or a couple of things that we need to do here. First, we have to determine the gradient of the given equation. But of course, we have to write it in the form y is equal to mx plus c. After that, we have to calculate or determine the gradient of the line which is perpendicular to the given line. After that, we need to determine m, the midpoint of the given coordinates. And then we can then substitute whatever we have determined here to get the general equation. So let's see how this works out on the board. We are given the equation y minus 2x is equal to 4. So we need to rearrange this equation so that it is in the form y is equal to mx plus c. And that's quite simple because we'll do this by saying y is equal to 2x plus 4, because this negative 2 goes to the other side of the equal sign. And from here, we can see that m, or should we call it m1, the gradient of the given equation, it is 2. Then from there, we use m1 times m2 is equal to minus 1, so that we can determine the gradient of the line which is perpendicular to that line. And this happens by m1, it is 2 times m2 is equal to minus 1. Therefore, m2 is minus 1 over 2. So again, this was the gradient of the original line. This becomes the negative reciprocal of this number. Therefore, this qualifies to be the gradient of the new line. Then the next thing, we are given two coordinates, 5, 3, and 1, 7. So we are given 5, 3, and 1, 7. We need to determine the midpoint of these 2 points. So our formula says m is x1 plus x2 over 2, semicolon, y1 plus y2 over 2. And all these should be in those brackets because we are determining a coordinate. How does this pan out? It becomes x1, which is 5, plus x2, which is 1 over 2, semicolon, y1, which is 3, plus y2, which is 7, again, over 2. You can see that 5 plus 1 is 6 divided by 2, it gives us 3. 3 plus 7 is 10 divided by 2, it is 5. So now we have got the gradient of the new line. We now have the coordinates where it casts or where it passes through. And how do we get this coordinate? It is the midpoint of some 2 given points. And so we used that formula to get that coordinate. Now we have got enough information to determine the equation of the new line. How do we go about it? We go back to y minus y1 is equal to m in brackets x minus x1. Y minus our y1 becomes this coordinate, which is 5, is equal to m, which is our gradient, which is minus 1 over 2, x minus our x1 is 3. Then we simplify that. It becomes y minus 5 is equal to minus 1 over 2x. Then a negative 1 over 2 times a negative 3 becomes a positive 3 over 2. So now from here, we then transpose the minus 5. So it becomes y is equal to minus 1 over 2x plus your 3 over 2, and then the 5 becomes a positive 5. This becomes y is equal to minus 1 over 2x. You can punch that in your calculator. It becomes your 13 over 2. You can leave it like this if you so desire. Some will want to say y is equal to minus half x plus, you can see that 13 divided by 2 is 6.5, which is 6,5. So it's well up to you to leave it like that or like that. Again, you can see that our equation is clearly done. The gradient is minus half as we determined it earlier on, and then everything has been done perfectly. In concluding this lesson, we have learned the following things. We have learned to determine the equation of a line which is parallel to another line. We also were able to determine the equation of a line perpendicular to another line. We identified parallel lines as lines that are equidistant from each other and that their gradients are equal, and that perpendicular lines intersect at a right angle, and that the gradient of a perpendicular line is equal to the negative reciprocal of the original gradient. And to determine the gradient from a given equation, the equation should always, and let's underline that word, should always be written in the form y is equal to mx plus c. In our lesson, which is coming next, we are going to derive the equation for the angle of inclination, theta, and calculate the angle of inclination. We are also going to solve typical examination questions, or a typical examination question, depending on our time. As I leave you now, I want you to take home this practice activity, which asks you to determine the equation of the line perpendicular to 2x plus 5y is equal to minus 10, and passing through the intersection of the asymptotes of the given equation. So you may have to do a little bit of homework to find out what an asymptote is. But I wish you all the best until we meet again.